addition, this is when we were partnering with IEEE and ISA at the Las Vegas Valley Water District. They did a couple power sessions that all kind of colludes together related to connectivity, Ethernet, and information is power. This is our last session related to close of that, and this is specifically utilizing your existing instrumentation. Most likely they have HART capability, utilizing the infrastructure of Ethernet that we kind of been over the last few months. So I'm going to pass the table over to Mr. Rich Velasco, and that's it.
Okay, well, thanks everybody for attending. My name is Rich Velasco. I'm a controls engineer with Wonder Malik. I've been with the company for just over a year now. I got my, just a little background about myself, since I'm probably a new face to most of you. But I got my degree from Northern Illinois University. Got a Bachelor of Science in Electrical Engineering and Technology. And I also got my master's degree in industrial management there. And during my grad school, I had the opportunity to be the teaching assistant for the automation lab there. So that was kind of my introduction into the automation world. First out of school, I worked as an electrical engineer for Siemens Energy and Automation, designing switchboards. And then I worked for a systems integrator that was mostly involved with food and beverage. So I got to do some neat projects with Gatorade and Kraft and Sara Lee. And that was before I got into water and wastewater. Okay, so I'm here to present today on using Ethernet to get HART data over an existing installation. But just to start out, a little history on HART, the HART protocol. It's been around since the mid-1980s. It was developed by Rosemount Incorporated. It was designed as a protocol to communicate to a range of smart instruments and devices to communicate over the standard 4 to 20 milliamp signal. It's based on the same technology that brought us caller ID over analog telephones. It was originally proprietary and was later published for free use in the 90s. So what is HART? HART stands for Highway Addressable Remote Transducer. It's become a global standard for sending and receiving digital information across analog wires. It's a bidirectional communication protocol that provides access between your field instruments and your host. Your host being, could be your HART device or PC monitoring system. And it's been used to obtain several types of information from your instruments, such as configuration data, diagnostics, and health status, and also to help with calibration. So this is a little bit on how the technology works. It uses a Bell 202 frequency shift keying, which is a modulation method which allows the digital signals to be superimposed on your 4 to 20 milliamp signal, where it gets decompressed later back into a digital signal. So there's a little extra information on Bell 202 and frequency shift keying, but with these two technologies together, it allows for digital communication over the analog without interrupting the 4 to 20 milliamp signal. And at those speeds, it allows for the 1200 baud rate, allows for a host application to get 2 or more digital updates per second. HART is also a master slave protocol. So basically, your slave device, such as your instruments and things like that, won't speak until spoken to by the master. And it can be used in 2 common configurations, which is point-to-point and multi-drop. But for the purposes of this demonstration, we're just going to be focusing on point-to-point. So I use HART, as we all know, it makes calibration easier. It's known for its reduction in maintenance costs. It's used to give early warnings to staff on variances in not only the device but also the process itself. It's used to continuously validate your loops, and it can notify the operator or the control system of a device failure. It's So some of the methods to obtain your HART data is wireless, as was presented in the April presentation earlier this year. Like methods such as using the thumb adapter. And there's also the standard wired method. And one of those methods is over Ethernet, which is what we're going to be talking about today. Okay, so why HART over Ethernet? Well, as we all know, there's an increasing popularity of Ethernet being used as the networking bus in facilities for control and monitoring. The protocol is well known to your system administrators. Ethernet itself allows for larger area networks to be created and beyond the traditional cable length. And it can be, and you can use commercial off-the-shelf hardware. And because of this, a lot of times in some facilities, the existing infrastructure can be used. You may have a PLC that's already talking Ethernet up to your SCADA system, or VFDs to your PLC. So to kind of introduce our demonstration that we had today, we're first going to go over your typical HART over Ethernet application. So here's this image here is showing your two-wire device, weak power, your analog input card. So to get it over Ethernet, we install a HART modem in series with the devices, such as the Spectrum field port that we have here for our demo. So like we were talking about, we were able to use the existing architecture by tying in the HART modem to the existing Ethernet switch. Okay, so we now have our HART data going to SCADA, but there may be some common concerns with having a configuration such as this. Maybe in a greenfield site where you have a new installation or a brand new plant, this may be okay, but can you guys think of anything, any pushbacks or concerns that maybe your instrument techs may have with this type of installation? Like a point of failure, maybe?
If it's like a resistor on the HART modem, it's less of a chance, but if it's a connection that has the capability of internally dying at the modem, then you lose that loop a lot easier.
Right, yeah. Mm-hmm. Yeah.
Also, what about another one concern is if it's not a greenfield site and an existing installation, why are you doing that? Is there a concern related to moving wires and stuff to plug it into that?
Yes. Well, if you kind of look back on how we added the HART modem into the circuit, we had to break the connection first, so you wouldn't be able to install it on a running process. So that's another concern. And then, like you were saying, Jeff, with if something internally with the HART modem goes down, now somebody has to fix it.
Yes. What we've experienced in the past is on modems like that, you might have a compatibility issue with your analog input card. And
Okay.
so you got to be careful about that. So you might end up with an isolator at some point in time, but it strictly depends on what that card is configured, if it's designed for a loop or if it's designed for a voltage source.
Okay.
If it's a voltage, it's got a 250 ohm resistor on it, then that loop integrity is not usually impacted by that. But if it's a current source, then you got to be careful about how that interferes with your AI card on your Modicon.
Okay. Okay.
So there's concerns.
Yes.
Okay. Okay.
I guess your point is, and maybe everybody would pick it up, that you just can't put it out there. You got to be careful and make sure that your loop integrity is maintained.
Right. Yeah. Okay, so there's us breaking the connection. So these are. Oh,
There you get this slide, that presentation, the breaking before you put it.
right.
Anyway, sorry. Continue.
Sure. Okay.
Actually, can you go back one, Rich?
Oh,
Those two-wire transmitters normally have a limited amount of impedance that they can push through, and sometimes people have a level indicator, like a local indicator, between the transmitter and the PLC. So if somebody had an indicator with a 250 ohm drop and your PLC with a 250 ohm drop, introducing this might push you over your limit of what the transmitter can push out. So
Okay.
some other concern to
That's
think
another
about.
good-
What would the fees be?
Right.
Okay, so here are the concerns that we just addressed. Again, the additional point of failure if the whole modem goes down. It may be more of a familiarity factor with your instrument techs. It might be something that are not used to dealing with. And we have to interrupt the process during the install. So it forced us to ask the question, is there a better way? Is there a better migration path to kind of introduce the technology to the staff? So here's the traditional analog wiring again, only this time we just put the terminal block in the diagram. We kind of show that for a specific reason. So instead of putting the HART modem in series in the loop, if we just sort of parallel off of those terminal blocks using those jumpers, and we kind of seen it with red line indicators when we want to have a kind of a door mounted display. And so to go over some of the common concerns that we had again. So if the modem goes down, we don't impact the process. The instrument techs can still troubleshoot the device like they normally do. And we could possibly install this while the process is running. We didn't have to break any wires. So here's the issues that we resolved. So here's kind of a table showing basically your traditional analog wiring versus your HART data. Traditional, all you basically have is your 4 to 20 milliamp signal. Some of the information that you pull from your HART, such as process values, your primary value, which is basically the digital version of your 4 to 20 milliamp. Secondary, if you have an ultrasonic sensor that has a temperature sensor as well, you can obtain that data and tertiary values. In terms of sensor monitoring, it can give you range and process alarms. If your process variable deviates between the upper and lower ranges, it can detect for a broken wire. You guys lose your signal to your transmitter. It'll let you know that too. And it'll give you device status, such as transmitter output signal is fixed instead of a live value. If a instrument tech was calibrating, left the device in manual mode, and it's no longer receiving live data, that could be something useful to notify. And it also does such things as the output signal is saturated and that the configuration is valid.
What does that mean?
Configuration valid is a comparison with your PLC limits between what is currently configured on the device. If somebody punches in a value outside of those limits, the system will warn of it.
Or can they change the scaling at the instrument, for example?
Yeah.
Would it be if you set it for 15 pounds, 4 to 20 milliamps, and you're overranged, and they go, wait a minute, before you do this, you might not want to do this.
Yes. Yeah. That's exactly what that warning's for.
Another intent maybe is a rogue instrument, a rogue technician. There's no rogue technicians, but someone changes the calibration intended or unintentionally, the configuration out of the field, and maybe it's a permit safety, your water, wastewater, or life safety, or gas emissions, or something to that effect. You change the parameter, and you have your master resource, and it tells you something is not right. Maybe it's correct, and now you change your resource at the PLC side and say, yes, they're agreeable now. But it's a way to prevent unintended consequences.
Okay, so that leads us to our demonstration. Let me switch this over. Do you want to introduce them? Introduce that demonstration.
Simply put, we threw together a little SCADA screen just to show, instead of showing all the motors and pumps, we just showed general data for one instrument. We just picked a temperature transmitter. You get some of We picked a temperature transmitter, a simple, very rudimentary device, just to grab some HART data off of it, just to show you some other data we could get. Just general information. There's a variety of stuff you can gather. We just cherry pick some items to throw up on the SCADA screen. He's going to throw that temperature module on ice to see that we are reading real data on the analog and HART data. Right now it's saying 73.95 degrees and we're inclining.
Is the one below it centigrade?
Sir?
Is the one just below it centigrade?
Yeah, I think most instruments, for example, Rich was alluding to a ultrasonic as a sonar device, and it needs a temperature probe to correctly account for that Doppler signal back and forth. So every ultrasonic has at least two ultrasonic sensor and a temperature sensor. So that's an example he was using that maybe you could grab that data as well. I think this very rudimentary temperature probe doesn't have a second sensor, so it's probably just giving that value to in Celsius is I think what we roughly calculated. Maybe a differential pressure transmitter might give you maybe 3 variables. I couldn't think of what else would give you a tertiary value. Maybe you know one.
I don't know, I work on valves where they give you position, give you input signal, and give you, like the pressure takes, the pressure sensor takes what your pressure is that it's driving it versus your position, your signal output to it.
And that's a HART module?
Yeah, it's a HART module. It's like Fisher actually put those on valves.
You guys have HART valves?
Yeah.
That's cool. How many HART instruments do you have under your domain? Yeah.
They're all HART, but we're not communicating.
Utilizing the HART data?
Yeah, we're not
Except for
utilizing
the
HART
handheld
data.
device out in the
They're
field.
using the handheld device to do the calibrations and any verification for trimming, zeros and things like that. They're pretty much not using the tools.
Right. At the City of Las Vegas wastewater, they have over 1,000 instruments, right? And was it at least 90% of them, I believe, is all HART.
Are they networked? I mean,
No, but they are not utilizing it.
We-
So
we
we
are-
are planning in the next 2 years of doing a migration plan to bring some of that data in.
if we build a pipeline that's going north, one of the requirements is to have HART over Ethernet back to our so that we can monitor the instruments that are out there. So if we can troubleshoot and identify the failure or something in advance, send somebody out there, we can tell them what
You know exactly what it is.
exactly what it is, what the failure is. If it's something that's not just a specific device, at least you can look at it and say, okay, this part's working, that thing didn't happen, what happened over here? And if there's some other failure, you gotta get an idea that maybe it was an analyzer that broke, or a tube that broke to a sensor or something.
In our, I'll get that in a second. In our demonstration, and actually back in September, we had the ProSoft ARC modem here. Unfortunately, we had to return it before this deadline, before this presentation. So we got the competitor Spectrum to do the same thing. Both the manufacturers said they were doing it, but they actually did not provide it as a remote in session HTTP type of session to see all the data. That was not provided in either module because apparently it's a separate chip you got to add to it. It was to bring that up as what I know several manufacturers. HART's been out there since a couple decades now. And for a while, several manufacturers, I talked to a couple, and they were not spending any calories to put out a HART communication device. In the past 12 months, I've had at least 2 different manufacturers saying their ProSoft and Spectrum are considering shutting down these lines, but while actual direct manufacturers, PLC manufacturers, are actually looking to adding these to their product line.
Third party, yeah.
Yeah.
Product line.
I'll bring that up. Earlier on, we were talking about our typical single connection versus a multi-drop, and we didn't discuss the pros and cons of those. The biggest weakness on a multi-drop unit is the more nodes you add to that multi-drop. You have one connection, one 40-20 milliamp connection, but it's really not varying. It's just powering
It's
those
power,
instruments.
it's a bus.
Yeah, it's basically a bus. And if you lose it
bus.
or a module dies and your response time plummets for every node you add to it, there's a lot of negatives. I see minimal benefits versus the negatives on going multi-drop. Hardwired, all the support staff knows how to maintain this.
Channel by channel by channel,
Yeah.
it's a dedicated circuit.
You know how to maintain it. You have you have only one point of failure, not multiple points of failure. So on this example, actually the instrument is scaled. That instrument's scaled 50 degrees to 150 degrees. So I don't know if you put it in there or not, but your 40-20 milliamp signal,
It's 3.91.
or others, is below 4 milliamps.
Yeah.
So your screen would be showing 50 degrees. I'm cool. That's all I was going to show you. The actual real-world instrument, the process variable is actually 42 degrees and dropping. And you were saying something else, Chuck, related to alarm or not?
The 1024 is the bit. It shows there's
That's
a problem with that
0.95.
particular channel.
It's out of range or something to that effect.
Uh-huh.
We didn't break it down to show individual bits. So individual bits would tell you exactly what's wrong, and we threw this together in a short fashion
Chuck,
to say something's wrong. But
is
we
that a
could do-
range because it's set for 50C and you got it colder than that?
50
Yeah.
degrees
transmitter.
Fahrenheit is the
0.
manufactured calibrated 4 milliamps device.
Yeah, and we're much below that with the ice pack on there.
Right. So this is a benefit, for example, in permit critical applications. Some of this data say, hey, like earlier you referred to a maintenance mode. Either guy forgot to put it back in the live data, you can see the live data, or also if it's saturated. Right now you're 50 degrees unscathed, but realistically you're 45 degrees, and it looks like you're climbing again because you took the ice off.
Yeah.
Put it back on the, before we have water running over there.
Yeah.
It's not that warm in here. I can look at the temperature and see what it is.
Anyways, we could actually broke down those bits and actually give you very specific problems related to that. And I know we all can break that code easily to say bit 1 is this alarm, bit 2 is that alarm. But we quickly throw this together to show you some of the general data available to you. This is all configured under HART version 5.0. Latest HART version is 7.0. Version 6 and 7 are primarily focused on the wireless HART stuff. However, there are some additional information related to the version 6 and 7 is that it actually can tell you the last time it was calibrated. Give you more specific calibration data.
It's got
Up
it's
through your
historical data stored.
Right. I think the last 10, depends on the series.
You-
So those are some additional benefits that maybe the manufacturers that are developing their HART modems and devices, maybe they can also grab that additional data. All this is version 5.0, which has been out for several years now. So there's more information. I don't know, the truth may or may not be beneficial to your individual situation, but it's saying there is even more information, and we just threw some parameters up there. Any other, you want to say anything else, but you're going to say something?
Well, when we get above 50 degrees here,
Oh,
One of the things that I've recently done on HART, is if you ever pick up the handheld calibrator, there is a ton of buttons on them nowadays versus the 9 that you had back 20 years ago. I'm dating myself, by the way, but you be very specific on what you're looking for and how you're looking for it, because button sequence is important, especially when you're actually looking for it. You guys got the software that's easier to set up on a host application than it is when you're troubleshooting out in the field. Most of the HART commands of it is there's a packet of these things that doesn't change between each device, because back in the early 90s, 93, 94, the ISA and IEEE, they standard on what everything's going to be in all these machines. So the cool part about HART is once you're familiar with it, you got a world opened up to you. And then, I don't know, there's a bunch of PDAs now that's got HART software that we use. Smart put out packages, and we got PDAs that can do everything off of those guys nowadays. You don't even have to have the calibrator anymore. We have some old ones.
you can adjust the calibration remotely.
Right.
I still believe you should be out at the instrument most often
A lot.
because they're.
Our managers won't let the guys go from back at the PLC and then calibrate the instrument.
Remotely.
They make them go all the way to the instrument.
Because the thought is, what do you want it to read? Is that the concern point?
That's the concern point. We actually, that had happened 10, 12 years ago. What he wanted to read, and they were just doing 3 and 4 point calibration, and we're finding out that zero shifting was killing us. And we had, our overall system error was up to 5%, 4.5%, 5%. And that doesn't sound like a lot.
That's my water bill's so high.
Yeah, it doesn't sound like, let's put that in perspective. 4.5%, 5% of 600 million gallons a day. Now think about that in numbers. That's a lot of water you can be off.
Hopefully it was to your advantage.
Well, especially if you guys.
Actually, it wasn't.
You have to report to the states because at the same time, how much on the discharge, the wastewater discharges.
Right.
So it's all.
That
has to
credit
be
that
accurate.
has got to eventually get to some point where they match.
Yeah.
So we had to go back through all our instruments, and then we had to tell the guys, look, you can't be doing this no more. You got to go 11 point calibration. And we bought
11 point.
Yeah, 11 points. We bought BMX calibrators that have the pressure and the current loops built into it, automatically created a calibration. They couldn't fudge no more. But they were all hard. They talked to them hard, and they monitored.
Even some of the brand newer instruments, and Ryan can allude to this, like for example the high-end mag flow meters, they will now tell you if they are outside of their manufacturer's specification in operation. Is that right? Mag flow meters, Brian?
Yeah, they do a fingerprint of them when they manufacture them, and it checks the electronics within both the sensor and the transmitter. It measures a bunch of values on it, impedance of the coil and all that when it's brand new. And then every number of period of years you can check. It'll do internal measurements on itself and tell you how closely that compares to what it was when it was brand new.
Yeah,
So
ABB does that. They built that onto that card. So, and the cool part is if you ever have a problem with some of those, and that card's got the integrity of your system, you got to move it. You just rip that whole shoot and match with you. It works pretty good. Scaling and ranging, it stays the same. The integrity stays the same.
But that happiness, that integrity happiness, because you really can't calibrate a mag meter, not in our installed basis. That would hopefully pass through the HART to say, hey, my instrument is no longer happy. Again, back to the HART situation.
And the biggest reason a lot of companies, especially in the water industries, the managers go, how do you certify that data on a frequency once, twice a year? How do you certify a magnet? That's why a lot of people go, well, I don't know.
A tertiary is, it didn't move with the ice. So it stayed pretty much at 23.
Yeah.
If it was, that's in Celsius,
That must be
it's
the
74
internal.
degrees.
That must be the internal transmitter.
Yeah.
sensor. Because if the ambient and that got to equilibrium, you would keep a calculate to make sure it matched. But if you warm the transmitter up and the temperature was sensing something else,
Yeah, it's probably handy to know your transmitter temperature, like at City of Las Vegas, well, LVW, anybody's transmitters, if they're only rated to 120 Fahrenheit, and your transmitter's in direct sunlight, and it's actually,
cooking.
yeah, cooking up to 130, 140, that would be good to know. So it's
Or-
another
absolutely.
great use of HART data.
Or misinforming you as well, outside of operate design spec,
Exactly.
and therefore misinforming you. So, sorry to take over this.
No, that's okay.
By the way, the tertiary is about 74 degrees Fahrenheit if that's a Celsius value.
Yeah, then we lost our.
Or your alarm bit went to one, from 1 to 0.
Yeah.
Yes.
So, any other questions?
Is this the display here? Where's the file that you would save to download to the transmitter? You got that on a separate location, or?
Yeah, that was actually done within the processor. There's some configuration parameters that we had to write to using, well, we use Unity, but to the modem over the Ethernet.
So this software you got run here is just the monitor software? It don't have the configuration?
We also configured that device.
Okay, so do you download to it, or do you do it online? Do you do it as you're actually looking?
Through the PLC program, you can use it to write the commands and the calibration into the device, all through a Modbus, in this case, Modicon, a write command, and it's right into that channel configuration. So instead of taking your handheld device,
You can just go
go through that and
the
go set
Ethernet
it.
software, say, boom.
Yeah,
Yes.
like at a greenfield site, you know, you got 20 instruments, initial configuration, type in all the parameters and go boom, and it writes to all 20 devices as long as they have their individual IDs.
Address, yeah.
That's just for this demonstration, that's how we configured it up. And we can show you the programming, but it's a pretty simple message block. Every PLC platform does it slightly different, but it's just a general typical message block type of function. And that, I guess, that concludes our HART demonstration. I appreciate Rich for throwing this together for us for today. We had some last month, 2 months ago, we had some other data besides the 2 VFDs and 2 PLCs all over Ethernet IP. We ran out of time. We had that ProSoft HART configured and set up. We also had a UPS and also a LTEC Lear power 24-volt power supply all plugged into the Ethernet, so we can also see those data parameters. But we ran out of time, and I thought this is the only thing really mostly applicable to finalize the Ethernet discussion of the past few months. That's it. Thanks very much. Thanks, gentlemen, and go eat. Thanks, Rick.